EA. First, EA operate on the finite and fixed size population of individual. Mean during development, okay, we need to decide number of population size for and then how to determine number of population size. Actually, we don't have any specific criteria to determine number of population. And then number of population is usually based on experiment. I mean, for example, first experiment we set number of population equal to 10. Then we run that program, the system we run, and then after that we got the result lah. So we keep the result. That one for experiment number 1. Experiment number 2, from 10 population we increase to 20 population, for example. Then we run again. So we have the result for experiment number 2. Experiment number 3, we increase to 30 population size. So we also have the result. So based on the result that we have, we do the comparison. So we know the the best result maybe at iteration at population number 20, for example, 20 population. Or maybe the the best result at population 50, and so on. So we don't have any specific criteria to determine the number of population. For example, like this, I draw like this. Okay, the graph look like this. Usually, this is what we call fitness function, or quality of chromosome fitness function, and then this is the number of iteration. So maybe this one we set at population size equal to 10. Population. So for this case, the convergent point at this point. Convergent point mean the value that not increase anymore. Okay, the fitness function just static. Okay, for example, this iteration, for example, 200 iteration. So after 200 iteration, the fitness function value still the same. But before 200 mean 0 to 100, so the value of fitness function keep increase till at one point the value of fitness function is static. Okay, is static. So we keep this result, then we do comparison after this. So and then another experiment, maybe the experiment look like this. The graph. This is the fitness function, and then x is the number of iteration. Then the point of what we call convergent at this point lah. At this point. So maybe here is 100. So 100 iteration. So for 20 population. So maybe if we compare 10 population and 20 population, 20 population better than 10 population, because at 100 iteration we have the result. Maksudnya number of iteration mean faster lah, the result get faster compared to 10 population. Kalau 10 population at iteration 200, maybe takes 5 seconds. But for 100 maybe just 3 seconds. 3 seconds we find the result, the what we call, ialah the result ni, second. So that show 20 population better than 10 population. So, and then maybe we can do another experiment. Maybe we can set to 30 population. So the graph maybe look like this. So maybe this one, 500 iteration. We found that at iteration 500, the conversion value at this point lah. So the 30 population is worse compared to 10 or 20. Clear? Should I repeat?
Clear, sir.
Clear, sir. I'm good.
So maybe 400 iteration, maybe the result after 10 seconds can produce the result. 10 seconds can produce the result. So takes more time to show the result. So that means the experiment number 2 is the best. This one is the best. So that we determine the population, how numerous should be our population. That one we can answer because we don't have concrete criteria for this question. How numerous should be our population? This is depend on the problem, depend on how we manage the what we call the problem representation. Okay, so then we should have the experiment. Okay, the experiment, multiple experiment. Okay, that one for size of population. And each individual chromosome consists of the same number of genes. Mean, for example, if we have 1 million chromosome, individual chromosome, so the number of column or the number of segment or the number of gene must have the same number of gene. For example, chromosome number 1 till chromosome number 1 million, so number of gene is the same. For example, if we have 10 gene or 10 like this, 10 macam ni, 10 1 2 1 2 3 4 5 6 7 8 9 10. So this is chromosome number 1, and chromosome number 1 million must have the same what we call column or segment or gene. 1 million. Same. And then the gene are composed of fixed number of bit. The gene, actually we set lah the number of bit, maybe number of bit. For example, we have 101010. So that just ni lah. And then because of we set just 8 gene mean 8 bit. So the maximum value for 1111 equal to what? 2, 4, 6, 7, 8 ni. Kalau 01 equal to 1, 10 equal to 2, 11 equal to 3. Kalau 100 equal to 4 kan? Yes or no?
Yes.
So kalau 1111 equal to maybe 1000 lah. Betul tak? 1000 or hundreds value of. So mean this 111 equal to quality of chromosome. This is the quality of chromosome. For example, 10101010. Ni, compared to A, this one katalah B. So A better than B, the quality of chromosome ni. A and B. So A better than B because
Tapi apa join sekarang?
the
Tadi
quality
kata
of A
10.5.
higher
Itu pun
than
join sekarang.
quality of B
Cepat
after
juga.
we convert to decimal. So that we compare lah how to determine the quality of gene. The quality of gene, so macam tu lah. How to decide. For example, gene number 10 better than others. So mean because of the value of chromosome number 10 higher lah, highest. And then two evolutionary operation are crossover and mutation. So mean we only have two operation. First crossover and the second mutation. Crossover mean we just like this, crossover like this. For example, macam ni, we have two chromosome. 2, 4, 6, 7. So we mix crossover, so we can get the children. This is parent lah. Parent and children. So children same, what we call same column or same segment or gene. 1, 2, 3, 4, 6, 7. So maybe at this point number at point 1, we do the crossover. So for example 1 0 1 1 1 1 1, yang ni 0 1 0 0 0 0 0. So after crossover, so the children maybe not like this 1 1 0 0 0 0 0, and then another children like this 0 0 1 1 1 1 1. So and then we evaluate. For example, for 1 0 1 1 1, the value, the decimal value maybe 120. Just letak je lah. And the second one for parent ni maybe 100. So children maybe this one 130, and this one maybe 100. So how to decide for the next parent? So we decide this one and this one. We consider the highest value, 120 and 130. So 100 and 100 we just remove. We consider as a parent for 120 and 130. So we follow the same process again, do the crossover again and so on. But before we evaluate the what we call, we evaluate the chromosome, we need to do the mutation. Mutation mean we set lah, maybe 5% or 10%. So kalau 5%, 5 over 10, 100 darab berapa? 8 katalah, 2 4 6 8. So equal to one segment lah, or one gene. So you need to flip by random. Kalau you just here 1, you change to 0. Kalau 0, change to 1. So that one randomly. So after that, after mutation, you evaluate the quality of chromosome. So you change the binary to decimal value. So dapat result. So just follow the same process. That one for iteration number 1, iteration number 2. For example, you set 1000 iteration. So you need to repeat 1000 time of process. Okay, ada soalan setakat ni? Any question before I proceed to another example?
Sir, the right page, the 120, that is the parent, right?
Yes, parent.
So we are keeping that parent for the next generation?
Yes, because we compare the current one and the previous one, we compare, then we just keep the best chromosome.
Okay, because I thought we can only keep the new the new generation for the next
new generation. If the quality is not good, so we not consider. We just consider the best.
Oh, okay, that's optional then.
Yeah,
Okay, I see. Okay, right, got it. Thank you.
Yeah. So the example, how the process, how do we do the process of EA, evolutionary algorithm. So that one for the population. So what should be the initial population? Actually, initial population and population is the same. Not the same lah. Initial population, okay. Initial population, we select the population by random. By random. Then we set, for example, we set 10 population. But the next population is not the initial is random, but the next population we select based on quality of chromosome, but still the same size, but the next population is better than initial population because we do the comparison like this. Macam ni. Clear?
All good?
Yes or no? Should I repeat or no need?
I'm okay.
Others? Yang lain?
Okay, sir.
Okay. Okay. So, how long should the evaluation last? Means stopping criteria. So how to decide the number of iteration? Stopping criteria mean number of iteration. Maybe sometime you saw at the article, maybe the article show the number of iteration 2,000, 3,000, 100,000, 100. So how to decide? So actually, based on problem. So you need to run, then see the result. So for example, like this, the conversion value at 200. So the maximum stopping criteria or number of iteration, just you can put 1,000. This is the maximum. So what happen if you put 10,000 iteration? Useless lah, because the result, because you find already the conversion value here. So the next value is the same. So no meaning. For example, if you set 1,000, or if you set 10,000, 1 million to 200 million or 200,000 and so on, the result just show the same answer. Like this lah, panjang macam ni. So no need. Just you put after the conversion value. So kalau tak, maybe you can put 500 only, also can. But must more than 200 lah. Macam tu. Okay, clear?
Clear, sir.
Yes.
Yes, sir.
That one for number of iteration. So, so discuss the statement below. So we discussed already the population, initial population, stopping criteria. So apa lagi? Okay, apa lagi yang you nak tanya? Ada? Tak ada?
Sir, saya ada soalan. So, yang mutation tu berlaku selepas kita pilih the best solution.
No. Mutation macam ni. Okay, first. Okay, sekejap. I buat new. Sekejap. Ini. First, we the what we call the flow chart. First, we set the population, initial population. This is random. And then after that, after initial population, we do the what you call crossover. And then mutation. And then evaluate the fitness function. Evaluate fitness function. The quality of chromosome lah. And then after we evaluate the fitness function, we choose the best quality ni. Choose the chromosome, the best quality ni. The chromosome mean the best quality lah. The best quality. Choose the chromosome, the best quality, and then after we choose the chromosome, we follow the same process ni kat sini. We do the crossover again. This process for iteration number of iteration. So kalau this is iteration number 1, iteration number 2, so you need to follow the same process. Iteration number 3, you need to repeat again till 1000 or till 500 iteration. Clear?
Clear, sir. Thank you.
So the mutation, you after mutation baru you evaluate the quality of chromosome. So how to evaluate? Using mathematical function. For example, for distance lah katalah. Kalau chest malam kan, chest fx equal to 28 minus x. 28 minus x. This is what we call the mathematical expression for chest. So to construct this, what we call this formula, this is the very difficult actually, very difficult to construct this mathematical expression to represent the problem. This is the what we call the highest ni lah, the highest part of optimization to solve. And then after you find what we call the mathematical expression or fitness function, so you just follow the same process je lah. You just follow the same process lah. Senang je lah. Tapi yang ni yang payah ni. So different problem have different mathematical representation. For example, problem distance. Okay, distance. You, for example, for delivery kan. Delivery maybe the fitness function like this. Xi minimum. Okay, Xi mean X1 plus X2 plus X3 plus Xn. So for example, location 1, location number 2, location number 3, you need to plus till n node. So you can get lah the total distance. So minimum. So then you compare the best chromosome is the lowest value of chromosome. This is the best. Sebab we set minimum, not maximum. Kalau yang ni minimum. Kalau this one maximum, because the best is no attacking each other. 28. Tapi kalau different problem is different mathematical formula. Clear?
Yes, sir.
That's why for your individual assignment, you need to show the mathematical expression for that problem, and then you need to explain the variable that you have in the mathematical formula tu. So explain every single variable. Dah jumpa belum artikel? Dah?
Masih mencari, sir.
Masih. Try cari lagi.
Alright.
And then so okay, tengok our notes, slide, anything that you want to discuss. Sebab kalau tutorial I think I dah cover for tutorial 1. So next week tutorial 2. So for this week I think enough already tutorial ni. So we proceed to ni lah our notes. Cuba tengok which part. Kalau tak ada, I nak you all concentrate on ni individual project. Try to find the related article and also discuss among your group member for group project. Also discuss the title also. Then itulah. Kalau tak ada nak tanya yang dekat dalam slide. Ada? Tak ada? Okay. Oh. Okay, macam ni. Kejap. Okay. Consider this figure. Okay. This figure represent, or this number ni represent this figure ni. 1625. Yang ni you faham ke macam mana nak tulis? Macam mana nak draw? Kalau nampak ni. Faham kan? Okay, satu. Ya. For second digit for row number 2. Third digit row number 3. Okay, yang ni okay, clear. Then the formula or mathematical fitness function, mathematical expression, mathematical representation for this case ni is ni lah, 28 minus h. H mean number of non-attacking pair of the queen. Okay, sebelum we ni I explain, you pernah main chess ke tak?
Pernah.
Sir.
Kaput tahu tak dia punya rules? Oh, you tahu tak dia punya rules?
Allah, member
Saya
tak
tak pandai, sir.
mute. Astagfirullahalazim.
Okay, so you tengok kat sini. The definition of the fitness function ni. Based on this, what we call this figure ni. For example, the fitness of the state below is 27 because queen in column number 4 and 7 attack each other. Column number 4 kat sini and number 7. Ni. So kiranya 1. So that's why the fitness function equal to 27. H mean attacking each other. H. Clear?
Clear.
Okay. That one for this what we call this example. Okay, another example. Okay, we assume we have 4 what we call, kat sini kan we have 4 chromosome. 2, 4, 7, 4, 8, 5, 5, 2 ni. So by randomly we pick up by randomly. So you draw again yang 2 4 7 4 semua ni, you draw like this, then you calculate the what we call the queen attacking each other, berapa banyak. So we have 4 based on this diagram or figure. So that's why 28 minus 4 equal to 24 kat sini. 7 we have 5 queen attacking each other and so on. Clear? That's why 24 ni consider the fitness function based on this formula. 28 minus 7.
Itu faham. Dia attack each other, dia tolak H. Okay, faham.
Clear?
Yang
Boleh?
faham boleh. Yang selection tu, yang biru.
Yang selection. So this one, the first column ni, the right side ni, the left side ni, this is by random. Random je dulu sebab initial population kan. So we set 4 for example. Then after that we do the crossover. We evaluate the ni. For the first iteration, we no need mutation. Mutation for second iteration and so on. First iteration, no need mutation. Okay. After we evaluate the what we call the chromosome ni, so we get the value quality of chromosome. So the best chromosome 24 ni kat sini 24 23. But here they choose three chromosome because 24 and 23 one pair, and then 23 and 20 another one pair. Pun boleh juga. Clear?
Clear.
And then do the crossover do like this, and then the mutation you just randomly flip the what we call the bit yang mana yang you rasa nak ni, just only one bit ataupun tak ada. Kalau tak ada pun tak apa, just because of random. Zero, sama ada 1 ataupun 0 or 1. Then follow the same process. This one one iteration, then follow the same process. We evaluate again, we evaluate the quality of chromosome, then we choose again, and then we do the crossover, mutation and so on. Clear?
So yang crossover tu dia random lah, dia ambil nombor mana.
Crossover tak random, dia bukan crossover. Crossover dia punya point of crossover.
Bahkan yang 327 48552 yang waktu yang dah pilih, dia asingkan dia pilih tu kan, dia tukar. So kat situ dia jadi macam random ke apa dia pilih nombor.
Mana? Yang the first yang row yang paling atas. Row paling atas. 327 48
kan dia ambil 327. Lepas tu
yang tu random. Sometimes you kalau for this case dia the crossover at point 3. That one okay. Kalau you nak buat crossover at point 2, so different lah dia punya answer. This example, the crossover occur at point number 3. Kalau you nak buat at point number 7 pun boleh, number 8 kat sini. 2, 4, 6, 7 kat sini. So the result is different lah. That one random. How to decide, how to determine the point of crossover ni, number of ni, that one random. Boleh?
Boleh rasa. Saya cuba. Rasa macam dapat sikit gambaran dia, tapi dia tak apa nak sampai kat ni.
Yelah, first time. Biasalah. Saya nak faham ni berapa lama. Bukannya satu kali baca boleh faham. 2-3 kali tengok baru faham. Sekali tengok macam faham tapi tak faham. 2 kali tengok faham sikit. Macam tu lah. 4 kali tengok, oh macam ni baru faham. Biasalah tu. Proses, learning process macam tu. Bukannya kalau kita baca buku cerita lain. Kalau baca buku sejarah, that one straightforward. You just memorize only. But this one, you need to understand, then apply. Different approach. Okay, so kalau ada soalan, tak ada kan? Kalau tak ada, I nak you all pergi dekat Google, try discuss dengan among your friend your group member. Title, apa nak buat, cari title and so on.
Excuse me sir.
Yeah.
Saya ada soalan untuk discussion group project ni. What kind of data set yang suitable untuk optimization?
Actually dataset tolak tepi je dulu. I just nak tahu. Tak ada tolak tepi. I just nak tahu the problem, the detail about the problem of your ni. And then after that, macam mana you nak represent that problem using mathematical formula.
Okay.
Yang dataset tu tak ada pun tak apa.
Alright, thank you sir.
Ya, lepas tu kalau you tak ni, you dapatkan artikel lah, tengok artikel dekat jurnal or related article macam mana. Then you just follow the article pun tak apa. Sebab I faham kalau nak buat you nak represent the mathematical formula, that one I think you kecuali you betul-betul brilliant, okay boleh. Kalau maksudnya you brilliant, mathematical, excellent, boleh lah. Tapi kalau tak, you just use or apply aja. Ambil aja kat mana-mana artikel, then use that formula. But you need to understand lah the process or the problem statement and so on, the objective, the goal and so on. Boleh?
Boleh sir, thank you sir.
Yeah.
Doctor, I have a question.
Yeah.
You said just now mutation takes place at the second iteration, not the first iteration. Is that only for that kind of problem, or is it applies to all problems in GA?
Actually, we standardize lah. We standardize. We follow the same process as I show you just now.
In the chess problem. Okay, because I thought the steps for GA is to create a random population, followed by calculating the fitness function, and then during the reproduction or selection,
that one for the first iteration. First iteration, you need to decide which chromosome the best.
Okay.
Because you want to do the crossover.
Okay.
Yang tu pun betul. That one also correct. Kalau my style, my version also correct. Dua-dua betul.
Okay. All right.
The same thing. The result is the same.
So it's okay to add mutation at the first iteration, and it's also acceptable to not add mutation at the first iteration.
Can also. Can.
Oh, okay. All right. Okay. Thank you so much. All right. Got it.
Any question? Ada? Tak? So kalau tak ada, I want to stop here today. So see you next class. So our topic for next class, genetic algorithm. So try to download the slide, go through the slide, try to understand, then easier for you to catch it, to digest during explanation. So bye. Assalamualaikum.
Salam, Doctor. Take care. Thank
you.
you.
Thank you.
Thank you.
Thank you, sir.
Attend your future.